Mercury is 36 million miles away from the Sun, or about 40% the distance to the Sun that we are. Mercury experiences the steepest temperature gradient of all the planets, ranging from 800 Fahrenheit during the day to minus 290 degrees at night. Due to its slow rotation, an observer on Mercury will experience one day in 2 whole years. This means you'd feel 700 hours of scorching heat, followed by 700 hours of freezing cold in just one day, sunrise to sunset. Mercury has tons of massive impact craters, similar to those that we see on the Moon. The largest one is over 1,300 miles across, likely due from a planetesimal smashing into it during the early solar system formation. These craters are billions of years old due to the geological inactivity of Mercury's surface. In other words, there's no plate tectonics to subduct these craters below the surface. Despite being 31 million miles further from the Sun than Mercury, the surface temperature of Venus is 100 degrees hotter. Venus is our solar system's hottest planet due to a runaway greenhouse gas effect. 96% of the planet's atmosphere is carbon dioxide, and the atmospheric pressure is over 90 times that on Earth. When looking at Venus, we cannot see the surface due to a thick layer of bright sulfuric acid clouds. We have managed to send probes through the clouds and land on the surface, but they can only capture images for an hour until they succumb to the immense heat and pressure on the surface. These probes revealed to us that the surface of Venus is dominated by volcanoes. Venus contains over 1,600 major volcanoes, most of which are now extinct. Theia Mons, the largest volcano in the solar system, is 800 kilometers across. Venus is the second brightest natural object in the night sky after the Moon. It's so bright that it has often been misconstrued as a UFO. In 1996, a Pennsylvania police officer followed a slowly rising saucer at 5 in the morning over 86 miles, only for it later to be reported as the planet Venus.
The Earth is the only world known so far to harbor life. There is nowhere else, at least in the near future, to which our species could migrate. Visit? Yes. Settle? Not yet. Like it or not, for the moment, the Earth is where we make our stand.
Earth is the densest object in our solar system. This is due to an event that occurred 4.5 billion years ago during the solar system's early formation. An object the size of Mars smashed into Earth and released trillions of tons of debris into orbit around our planet. A mixture of centrifugal force and gravity caused this debris to coalesce into our moon. The Earth was spinning violently from its recent collision, but the gravitational tug of the moon helped slow us down to our 24-hour day. It also turns out that the formation of our moon gives our planet its most unique characteristic. Earth is the densest object in our solar system. Our strong magnetic field is a byproduct of early planet collision. This field safeguards the entire sanctity of life on our planet. $135 million miles away from the Sun lies Mars. Rovers that are continuously exploring the Martian surface today have sent back images of canyons and rocks that were eroded billions of years ago when Mars still had liquid water coursing through its veins. So that begs the question, where did all of Mars's water go? Well, it has to do with its magnetic field. Mars is about half the weight of Earth, and because of this, it didn't have enough gravitational force pushing down on its core. As a result, its core solidified. Once its core became solid and not molten flowing, its magnetosphere stopped. This left the Martian atmosphere exposed to harmful bursts of solar radiation. Massive solar flares would hit the atmosphere of Mars and coil it up like a rope and then vaporize it, blast it right off the surface of Mars. Without an atmosphere, every time the water would evaporate, it would no longer rain back down on the planet with clouds and rain. Instead, it would evaporate back into space, which is why Mars is such a vast, barren desert that we see today. Mars has deep canyons 23,000 feet below the surface, and volcanoes such as Olympus Mons that tower 70,000 feet above the surface. The surface temperature of Mars is a balmy minus 40 degrees Fahrenheit, about the same temperatures you'd experience on Antarctica. I'd like to thank you all for embarking on this voyage of the terrestrial planets with me. And as always, keep looking up.